Hello, it's Miss Haynes again. I'm going to talk about combining similar terms or like terms and equivalent expressions and just a couple examples of simplifying some linear expressions. Combining like terms just means if I've got two or more terms that have the same variables, you can add and subtract the coefficients however they're added or subtracted, and then you can simplify that into one term. Constants are always like terms, always, always. So for example, if I had the terms in a row 2x plus 3x minus 4 minus x, I would go through and I'd say, all right, 2x, that's a term with an x in it. 3x, that's a term with an x in it. Minus x, that's a term with an x in it. My coefficients are 2 and positive 3. And there's a minus sign here, so this is like negative 1x. You can think of it like that. The 1 is just never written down normally. So it's like 2 plus 3 minus 1. 2 plus 3 is 5. Minus 1 is 4. So altogether, I have 4x. And I look at the constants, I've got minus 4, negative 4. Just put that on down there. That's all combining like terms is. If I'd had another constant, I would have added it with the negative 4, and I would have had a different number there. This is the simplest form of a linear expression because all of my x stuff is in one term, and all of my constant stuff is in one term. I don't have my x's all spread out everywhere. Equivalent expressions are just things that'll simplify down to be the same value if it's all numbers, or the same linear expression in the simplest form. So all this stuff over here as one expression is an equivalent expression to just 4x minus 4. All right, so at the bottom of this, there's a work page, and there's these two examples, and they want you to be able to justify what you're doing. And to simplify a linear expression, the first thing I always look for is, can I distribute something? Now, why do I start there? Normally, order of operations, you start with, can I combine anything inside of parentheses? But most likely you can't because you'll have x's and you'll have constants, so you won't have to worry about doing the p part of PEMDAS. You won't have to worry about the e, the exponent part, because it's linear. You're not going to have anything squared or raised to any powers, no 5x cubed, nothing like that. So you won't have to worry about that. So then you look to multiplication. And if you're just doing linear expressions, the most common thing you want to work on first is distribute something. Distribution is just multiplication. It's taking a multiplier outside times a sum and turning it into the sum of two products. So in this case, and to look for distributing, look for a number outside on the left side of parentheses. Or I should say a negative sign, because you can distribute that as well. On the left side of parentheses, that is not added to the parentheses. In other words, if I had 4 plus and then a parenthesis, I'm not going to do 4 times anything in there. It's added, not multiplied. If it's just next to it, there's nothing like there. Negative 3 times all this stuff. So I go with negative 3, and I'm going to multiply the negative 3 times 4x. And to do that, you do negative 3 times the 4 to get the number, and then times the variable that's there. So negative 3 times 4 is negative 12, times x is x. And that takes care of that term. Then I'm going to hit negative 3 times positive 3. Negative 3 times positive 3 is just negative 9 or minus 9. And I'm going to have to just bring this stuff over here down. I don't multiply this by I don't multiply -3 by 5x because this is outside the parentheses. The only stuff that's dealing with multiplication is that stuff right there. Up until I distribute, this is like one giant term. And that's what it equals to. So then I have to have plus 5x towards the end there. And the justify column wants to say what you did. The only thing I did from here to here is I distributed. So I use distributed property. We can write distributed is what we did. I'm going to write distributed because that's the property that was used. Now it gives you a lot of lines to use up, and there are a lot of ways you can make things look simpler for you. One thing that's a common thing to do right here is you say, okay, I'm going to make sure all of my like terms are next to each other so I don't lose anything. So I'm going to go and I'm going to say I've got this minus 12x or negative 12x at the front. I got this positive or plus 5x. Those guys all have x in them. So I'm going to use the commutative property to move this guy closer to that one so I can see them next to each other. Okay, and I can't forget this minus 9 or the negative 9, so I'm going to make sure I put that in as well. And that was using the commutative property. Remember, we can use the commutative property even if we've got subtraction signs, so long as we keep that minus sign next to the right in front of that 9. We keep them together. Okay? Because it's just like adding minus 9, adding negative 9 to it. So the more you do stuff like this, the less likely you'll have to actually make this step. Because right now you can look and you can see I've got negative 12x plus 5x. Negative 12 plus 5 is negative 7. I'm going to keep that x with it because that's the kind of thing I'm adding together here, is x's. Then I got to bring down my minus 9. And that was combined like terms. At this point, one of the questions people have is, how do you know you're done? Well, I have one term right here that's got x in it, and I've got one term right here that's just a constant. I can't combine them because they're not like terms. There's nothing multiplied. There's nothing else to do. I have simplified it. That's all I need to do. I don't need to factor anything. That'll complicate matters again. All I got to do is just be done. You may have an extra line underneath this. That's okay. Some people don't even need to write down this step here. They just skip over it. Don't skip it. They do it in their head. So that's how you simplify. For this guy here, one of the first things you can do is you can recognize that everything here is just added. Everything inside these parentheses is just added and subtracted in a row right there. There's nothing outside multiplying. If you want to think of it as though there's an invisible 1 here, 1 times all this stuff, you can think of it like distributing. But really, we want to think about the associative property and how if I'm just adding these things to whatever this is, then the grouping doesn't matter. It doesn't matter that they're all in parentheses together. So I can rewrite 3x plus 6y minus 4 plus 2 times the quantity x minus 6. I can think of that as just using the associative property, get rid of those parentheses. Let me draw my lines. Okay. And I could have done that at any point in the game. I automatically just take away parentheses if there's nothing out in front multiplied by them. I don't even think about it. But I want to make sure that you know that that's why we can take the parentheses out, because it doesn't matter. It doesn't matter how I group them. It doesn't matter what order they're in or how I group them if I'm just adding them. The thing that does matter is this guy here, because he's being multiplied by both pieces. So if I'm going to distribute this one, use the distributive property. 2 times x and 2 times a minus 6. I'm going to go ahead and just bring these guys down because I don't need to worry about them yet. Until I have something to combine with them, they are just terms that I can't put together. I can't just add the 2 to the minus 4 and make it a negative 2, minus 2, because it's not just a 2, it's 2 times all the stuff in here. Okay, this is a plus 2. I'm going to leave my plus sign here. This is a positive 2. 2 times x is 2x. And 2 times a minus 6, well, I could say plus negative 12, or I could just write negative 12. I like to just write negative 12, because I know what 2 times minus 6 is, minus 12. That works out for me. If you want to use a commutative property, that's the time to do it. Now that I have just terms, I have nothing else I can multiply and change anything. Let's use commutative property. Make sure all of the things are next to each other. Commutative, make sure I spell it right. I'm going to put all of the x's together. So I've got 3x, I've got plus 2x, I'm going to put them next to each other. I've got plus 6y, and that's the only thing with y in it. I don't want to forget to write everything down. And let me just underline my constants. I have a minus 4, a minus 12. I've just rearranged everything so that I can take a look and see what goes together. 3x and 2x. 3 plus 2 is 5. That's how many x I have. I only have 6y. That doesn't change. I don't have any other y terms to use or to worry about. Then I've got a minus 4 and a minus 12. So the key here is not to turn this into 8 or negative 8 somehow. Sometimes people think, well, that's obviously 4 minus 12 is 8. They ignore that minus sign in front of the 4. If I have a minus 4 and a minus 12, that's going to be negative 4 and another negative 12 in that direction. So it's going to be minus 16. And that's using combining like terms. How do you know if you're done? You look at that and you say, okay, is there anything else that has x in it? Nope. Is there anything else that's got y in it? Nope. Is there any other constant? Nope. I have a term with all my x stuff, a term with all my y stuff, and a term with all my constants. That's it. I'm done. I'm trying to think if there's any other notes that I had with this. I think that's basically the notes I had with it. If you guys have any questions, give me an email. Let me know. Have a great afternoon.